All right. Are you ready for the next wave of embodied carbon compliance? Well, Erika Winters-Downey is. Erika is the Associate Principal and the Director of Sustainable Structures for Clayco Lamar Johnson Collaborative Enterprise. With a breadth of experience spanning structural design, technical institute, and construction, her experience allows her to drive success from project pursuits through design and construction. In her current role, she works across the enterprise to lead embodied carbon reduction strategies.
Awesome.
Thank you, Erika.
Thank you. I'm really excited to be here. My background is structural engineering, so I'm definitely very intimidated by all the energy modelers out here, but I also help lead a group that does energy modeling, so learning a lot as we go. So I will also say to, give props to what Katie and Brian talked about. I'm the chair of the Green Building Council in Kansas City, and we also have an energy resource hub there, and I know that they interact quite a bit. And so it's been awesome in Kansas City to be able to partner up with what's been going on in Illinois, so it's really cool. So I said, yes, my background is structural engineering. I worked here in Chicago for a while for the Steel Institute, and I've worked at design firms as well as general contractors before starting this role as Director of Sustainable Structures for LJC Clayco. So I think I'm part of a pair here where we're doing a shorter presentation and then a panel. So I'm briefly going to talk about what's coming up for embodied carbon, where are we now? So essentially, if you haven't been able to grasp, embodied versus operational carbon, essentially operational carbon is what's going on here right now with the lights and the HVAC and everything. And essentially for the last 20-ish years of the green building evolution, most everybody was focused on that aspect, like how efficient are our buildings operating, and legitimately so. It's a large source of energy and carbon. And then the last 5 or 6 years, people have been saying, well, our energy codes have been getting more stringent. It's probably time to tackle how much carbon goes into making steel, concrete, et cetera. And when people started running the data, yes, it is a lot of carbon. So with anything else, when you start talking about embodied carbon, there's vocabulary to go along with it. So not to get too crazy into the weeds, but essentially, like my last slide, essentially the last 20 years or so of the green building evolution has been focused on what somebody who does a whole building life cycle analysis would call B6, B7, like the use of the building. And so I live over here. As a structural engineer, I live here in this world of A1 to A3. What happens when we recycle metal, make steel beams? What happens when we take cement out of concrete, do all those things? So where can we be creative? There's several ways to tackle this, right? We can tackle it with smart design, and we can tackle it material science-wise. And so I know probably this group is no stranger to a fact that like roughly 40% of our emissions globally are from construction, building related, and roughly 11-13% are from materials. Essentially, people have been saying, okay, embodied carbon is really urgent to tackle, because when a building is built, it comes with its embodied carbon. Like, this concrete is here. And maybe 20 years down the line, there's a renovation and it bumps up a little bit. But, as operational carbon grows over the life of the building, that carbon is here now. So arguably it's being put in place faster. So, and we've all seen the slides as well about building in New York City every few years. So it is something, important. And I like to tell the anecdote that I was at Greenbuild like 4 or 5 years ago in a session where they were talking about embodied carbon, and they said, we need a structural engineer. We need somebody who knows what they're talking about here. And so a couple of structural engineers and I were talking, we're like, when did the structural engineers become the cool people in the room? Because we're not. So it's been an interesting time. So again, why is structure important? Why are we talking about this? This is from the Colorado Buy Clean Act. So, and this holds true with the embodied carbon studies that I've run. So this would be like a steel framed office building. entirely steel framed metal deck, just concrete slab on deck. So you can see even with just like the concrete slab on deck fill, that's a pretty large chunk of the concrete, and then steel is after that. But kind of rough rules are like for new construction, depending on the type of building, like parking garage might be different, but usually embodied carbon is 80%-ish from the structure. So then kind of going with what's here now, what's coming up, similar to what we talked about earlier, there's, here's a map of building performance standards in the US. And where I am in Kansas City, we're under consideration, just like you guys, we're working on it. What is here now is whole building LCA requirements. So, states like California, they've got Cal Green, the new, that law went into effect July 1. So any building over 100,000 square feet has to complete a whole building LCA, which goes through end of life, which a lot of times our best data is up here in raw material supply, and some of these other factors wind up being multipliers. But I also really like this graph from the Rocky Mountain Institute because it kind of gives these average factors for embodied carbon. And this is from the environmental product declarations that I've looked at. This is pretty true. The ones that I've seen that go through the end of life, yes, still the lion's share of everything is up front. So there are regional embodied carbon regulatory compliance as well. I think Marin County in California was one of the first ones. There's a Buy Clean Colorado. Minnesota has one. They're popping up all over. We don't have one in Kansas City yet, but we're still working on getting the energy code and the performance standard right, so we'll get there. We do have GSA Buy Clean regulations, so if you're working on a project that's getting funding through the IRA or the BIL, a lot of that material is subject to embodied carbon regulation, where you have to submit an environmental product declaration saying my steel is below X and my concrete is below X. So it's been great. There's actually a couple architects who work for the GSA and specialize in this in Kansas City with me, so I get to pick their brains about it once in a while. And then this is some of the Cal Green provisions as well. So the confusing part is when it says tier 1, tier 2, essentially this is what they're saying, like this is in effect now, and then tier 1 and tier 2 are like what they are gonna step down to over the next couple years. So really for concrete and a lot of other materials right now, as of July 1, like these thresholds are set at 175% of industry average, which is pretty generous. Like they're really baby stepping into it. Like they're taking out like the worst offenders type thing. And so I actually just interviewed for a project yesterday in California and said, yes, we have no problem meeting this for the job in California. A few years down the line, we'll have to look more specific. And then this is just another list of some more of the embodied carbon policies out there, from requiring EPDs as well. And then what I'm gonna touch on in kind of the what's next type area is really the hot topics of like deconstruction and reuse. So I was lucky enough to participate in the SE 2050, and the SEI Institute had a convening in July in Boston where they were kind of trying to map out like what is the path to net zero for structural engineering. And I would say the breakout that we had on deconstruction and material reuse was probably the most energized type one. So one to watch is San Antonio. They have a deconstruction ordinance in place. So, I mean, you can imagine if a city the size of Chicago said you cannot demolish anything anymore, it has to be taken apart, like a kit of parts, and documented. So I know that there's, size thresholds that go along with that, but I think Vancouver in Canada also has a deconstruction ordinance. And we used to talk about this when I was worked for the steel industry as well, that, you have steel from a mill, but then you also have service centers, which are kind of the Home Depot lumberyard of steel. And there could be the Honda pre-certified used lot of this, but how do we de-risk that for engineers? What is next? Building testing into project budgets and schedules. So Clayco, Lamar Johnson does a lot of industrial, large data center type work. And so I do have some slides at the end. I hope I copied them in here, about we are starting to do way more testing for clients and starting to build it into our projects and schedules. So when we are awarded a job, this would be for California, our concrete contractor and ready mix supplier says, we feel comfortable with these mixes. If you want to really dial it in, we need to do some testing, before throwing these mixes on a 1.5 million square foot warehouse. So allocating $100,000, $200,000 to doing some testing can be done on some of these larger projects, as well as it can also be done cheaply. We've done projects where for a large data center, we're putting up a lunch tent on site for the workers there. So that slab for the lunch tent is our test slab for the low carbon mixes. Also, what's next, and this is something that's come up in the UK recently, kind of getting to that, used material side. So if I'm a structural engineer. Actually, my license is in Illinois now that I think about it, because this is where I lived when I got it. But if I want to take this used steel beam and use it in my building, I am probably taking on a decent amount of liability from the building code itself. So how do we go about saying, yes, this lot of steel over here is good to be reused? What are the full cadre of ASTM tests I need to run on this thing in order to feel confident about it? So I think that's going to be something that's going to be a hot topic the next few years. And then, this is some of the testing that we did last November. So this was for a data center client of ours. So they essentially said, there are all these really innovative concrete products out there that you see, right? All these low carbon aggregates, all these things. But what's available to us now, what's available at scale that we can actually use and not chip away 10, 20% at our carbon footprint, but what's going to get us to the 40, 50, 60% that are in our corporate goals. So, Clayco has a really robust concrete strategies group, and they have pages and pages of quality data requirements, and they're very strict about, before we put this mix on, we've got to look at the aggregate, we've got to look at this. So similar to what I said, we said, we've got a test yard in St. Louis, let's build some of this stuff. So these were all the groups involved. Ozinga here in Chicago, and it is kind of notable that Keenstra is a big ready mix supplier in St. Louis. They're direct competitors, so they were both helping on this. We worked a little bit with Breakthrough Energy and Climate Works as well. So we essentially said, we're going to benchmark these. And whenever somebody says, oh, you need a 30% reduction from your concrete, it's really important to ask versus what, because there are a lot of different benchmarks out there. The NRMCA is the National Ready Mix Concrete Association. They have benchmarks from 2020, which are pretty generous. And then they have a newer set of benchmarks from 2023, which are a good 30% lower. So if you are, depending on where you are, you've got to read your spec and ask what are you asking me to benchmark to? So we did our base, and this was interesting in itself. was 100% type 1L cement. So 1L is the newer mix that has like up to, I want to say like maybe 12% limestone in it. That mix itself was actually a 25% reduction from the regional baseline because this St. Genevieve, Missouri plant is actually one of the most efficient in the US. So regardless of anything else, like, different cement plants operate differently. And then panel 2 was a 25% blast furnace slag, and then panel 3 was a proprietary mix from Ozinga, which was going to be about a 64% reduction. But it's one of the bigger ones that like it's newer, but like you can get it at scale. And so in addition to like just saying we can cast this stuff, for tilt wall construction, I'll go back to this picture. It's kind of like having a post-tension slab where they, per the schedule, say, we're going to cast this, we're going to tilt it, and then like we want to tilt it. Most aggressive would be like 3 days. Sometimes it's 5 or 7, and it doesn't have to be full strength by then. There's all these different thresholds. Like usually you want 50% strength by the time you're tilting it. So we wanted to hit strength on time, but we also like wanted to make sure that these guys in the field who are pumping it and placing it and finishing it can work with these mixes because they're different and they're stickier and you're playing with a lot of different things. So that 1157 is not like a brand name. It's an ASTM spec. So there's ASTM 1157, which says you can put it. It opens the door wider for what you can put in cement. So we worked with Wisjani. We had a lot of strain gauges and in situ sensors and all the things. Essentially what we did was the panel 2 with the 25% slag actually got hit strength faster than panel 1, which was great in itself because actually when we poured this, it was like November. It was like 19 degrees out. So it was like a good cold weather test for the concrete. But because of those speed times, like a lot of the low carbon mixes will slow down strength gain. So now at least we have a mix where the client knows, okay, we can do this 25% substitution even in the coldest of weather, and like we're going to be good to go. And then this was for panel 3. Like you can actually see the difference here, like the color difference between them. It finished beautifully, but it was harder to pump out. It took like a couple trucks to get like the moisture and all that stuff right. And you really, when they say like once you use the Vibra Strike, like it would come out, it was kind of sticky. You had to put this little vibrating machine in it and then it would move around and you could place it. But so there's just like, in addition to carbon and strength, like you got to be able to work with this stuff in the field because everybody knows like something like that will kill a good idea just as fast as anything else. So we're just starting, actually we just finished the second round. That was last year. We just finished the second round of testing with that same client down near Atlanta, testing an ingredient called calcined clay, which is pretty neat. But yeah, so we are, trying to be aggressive about working with these clients on projects where we have the time to really dial in some of these mixes. And I will say on the, I guess to translate maybe some of the carbon reduction that was there, when we present to clients, there's an EPA greenhouse gas equivalencies calculator that you guys probably use in energy modeling where you can say, you're saving 1 million kilograms of carbon and it's equivalent to XYZ. So, yesterday when we presented in California, we were presenting a 20% reduction as a minimum and saying, okay, here's a couple things we can do to get you to 30. But even that 20% was, I want to say 11 million kilograms, which was equivalent to 3 wind turbines running for a year. So, it's significant. Like there's significant savings there. So We as structural engineers just have to be able to speak to it. So essentially to finish up though, like what can you guys do? Like make sure you're asking your clients up front, like what are your carbon reduction goals? We approach a lot of interviews by saying, by doing our research on their website, this person has this carbon goal, like how can we match up with that? Ask your vendors for the environmental product declarations. Can we help you do testing? Like, do you have time to, have us help you dial in some of these mixes? Get to know your concrete suppliers. It is pretty interesting to tour a steel mill or a concrete plant. Performance-based specifications. I love the theme for Wild Wild West today because I've been saying that for a year on the embodied carbon side of thing. Like it's a little bit of the Wild Wild West because ASHRAE has this lovely chart that says, here's your building type and here's your baseline system, and that does not exist. So for embodied carbon, so we're trying to figure out the best path we can. And then, if you are a structural engineer, I had like 5 more slides about put these things in your general notes, but you guys don't need to hear all that. So I think that's all. That's all I have. So thank you so much.
Yes, thank you, Erika. Thank you very much.